Hello, grade 8. In this video, I'm going to answer the questions that you are supposed to do as a homework. Questions 12, 13, 14, and 15, pages 25 and 26. So let's start with question 12. The table shows information about a train journey. Let's have a look at the table. The labels are the station names, Ayton, Beeston, Seatown, Deville, and Eton. We have the distance traveled between each two stations. At the beginning, from Ayton, the distance traveled was 0 kilometers and the time 0 minutes. When the train reached Beeston, the distance now is 20 kilometers and it took 30 minutes. From Beeston to Seatown, the distance is 28 and the time taken 45 minutes. From Seatown to Deville, 36 kilometers and 60 minutes. And finally, between the last two stations from Deville to Eton, 44 kilometers and the time 70 minutes. Use the data in the table to plot a distance time graph for the train. Find the train's average speed between Beeston and Deville and give your answers in kilometers per hour. So you have to pay attention to all what's asked from this question. The table gives us the time in minutes, but the final answer for the average speed between these two stations needs to be in kilometers per hour. To plot a distance time graph, first of all, we need to label our axes. Time on the x-axis is given in minutes, and distance on the y-axis is given in kilometers. Okay, let's see how are we going to divide our x-axis. The time ranges from 0 minutes to 70 minutes. We can divide it into tens on the x-axis. 10, 20, 30, 50, 60, 70, 80. Okay, and the distance ranges from 0 to 44 kilometers. So we can also divide it in tens as well, but we can use two grids for each 10. So 10 kilometer, 20, 30, 40, and 50. So here we have 10 divisions. Each division is 1 kilometer between each marking on the distance axis. Let's start plotting our distance time graph. The first set of data, 0 kilometers, 0 minutes. So this is our first point. At 30 minutes, the distance is now 20 kilometers. So we plot a point between 30 minutes and 20 kilometers. At 45 minutes, the distance is 28 kilometers. 45 is in the middle between 40 and 50. You can use a ruler. And I need to plot a point between 45 and 28. So 28 is at this point here. So here's my point. The next set of points, 60 minutes and 36 kilometers. 60 minutes. This is 30, 35, 36. 70 minutes and 44 kilometers. 70. This is 40. This is 44. Now we need to connect our dots. Straight lines with a ruler. Speed is changing, so it's not a straight line. We have different sections in this graph. Okay, so this is our distance time graph for this journey. Now we need to find the average train speed between Beeston and Deauville. Okay, so as not to mix up these stations, we need to know where each station starts. Let's number them. This is 1, 2, 3, 4, and 5. So the train sets off from Iton, this is 1, and it reaches Beeston, this is 2. Then Seatown, 3, Deauville, this is 4, and Eton, this is 5. We need to find the train's average speed between Beeston, 2, and Deauville, 4. So we need to find the average speed between these 2 points here. Remember that the average speed on a distance time graph is the gradient of the graph line on the distance time graph. So, average speed between Beeston and Deauville is the gradient of distance time graph. Okay. The gradient equals distance traveled divided by time taken. So what's the distance traveled between these two stations? The distance is the difference between this point and 36. So if we draw a vertical line here, we will have a vertical line representing the distance, which is the difference between y2 minus y1. y2 is 36 minus y1, 20, and the distance traveled is 16 kilometers. The time taken is also the difference between these 2 points, 30 and 60. x2 is 60, x1 is 30. So this horizontal line here of this triangle shows us the time traveled, x2, or time taken, minus x1, 60 minus 30, the time is 30 minutes. Okay, so the distance traveled from the distance time graph is the difference between the 2 points on the y-axis, y2 minus y1, divided by x2 minus x1, y2 minus y1, 36 minus 20, divided by 60 minus 30, and it equals 16 kilometers, pay attention to the units, divided by 30 minutes. Now our question wants us to calculate the final or the average speed in kilometers per hour. What do we need to do now is change the value of time from minutes to hours. To do that, 30 minutes equals in hours, we divide it by 60, so it's half, 0.5 hours. Now we replace the 30 minutes with 0.5 hours, so 16 kilometers divided by 0.5 hours equals 32 kilometers per hour. Every bit of information in the question is very important, So you need to read the question fully before you start answering, pay attention to the units used, and do the necessary conversions for every part of the question. Question 13, page 26. Which of the following could not be a unit of acceleration? Let's remember the formula of acceleration. Acceleration equals change in velocity divided by time. We said that velocity is speed in a direction, so the unit of velocity is the same as the unit of speed. In order to have a unit of acceleration, we need to have a unit of velocity divided by a unit of time. Now the question wants us to know which of these could not be. So let's check each unit. Kilometer per second squared. This is a unit of velocity, kilometers per second divided by a second. So yes, this could be a unit of acceleration. Miles per hours per seconds. This is miles per hours, a unit of velocity, divided by seconds, a unit of time. So this also could be a unit of acceleration. Kilometers per seconds. This is a unit of distance, kilometer, divided by a unit of time. So this could not be a unit of acceleration. Meters per second squared. This is a unit of velocity, meters per second, divided by a unit of time, second. So this also could be a unit of acceleration. The unit that could not be a unit of acceleration is kilometers per seconds. Question 14, page 26. A car sets off from traffic lights. It reaches a speed of 27 meters per second in 18 seconds. What's its acceleration? So let's start with what we know and what we need to know. The car sets off from traffic lights. Sets off means that it was stationary. So it started from a velocity of 0 meters per second. So the initial velocity, u, equals 0 meters per second. It reaches a speed of 27 meters per second. So the final velocity is 27 meters per second. In 18 seconds, the time taken was 18 seconds. What is its acceleration? We need to know acceleration. A simple question. We need to use the formula. Acceleration equals final velocity v minus initial velocity u divided by time. The final velocity is 27 meters per second minus 0 meters per second divided by 18 seconds. So 27 meters per second divided by 18 seconds equals 1.5 meters per second squared. Or we can say meters per second per second. The final question, question 15, page 26. A train initially moving at 12 meters per second speeds up to 36 meters per second in 120 seconds. What's its acceleration? Again, what do we know? We know the initial velocity, u, equals 12 meters per second. It speeds up to 36 meters per second. Final velocity, v, 36 meters per second in 120 seconds. So the time taken was 120 seconds. What's its acceleration? A is missing and we need to calculate it. Acceleration equals final velocity v minus initial velocity u divided by t. V is 36 meters per second minus 12 meters per second divided by 120 seconds. 36 minus 12, 24 meters per second divided by 120 seconds. The answer is 0.20 meters per second squared, or meters per second per second. This is it. If you think that some points are still not clear, please send me a message and don't hesitate to ask. I can clarify anything that you don't think that you understand.